So we're going to build on what we talked about yesterday, the law of sines, and we're going to talk about the law of cosines. So for the law of cosines, the situations where you would use those is if you're given three sides, side, 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 or two sides with the angle between them. So side, angle, side. Remember that order is important. The angle is literally between those two sides. If we have those situations, we can use the law of cosines to solve the triangle. And remember, we're dealing with oblique triangles, triangles that do not have right angles. So here's the law of cosines. So given this triangle, remember, big letters are our angles, and little letters are our sides. And remember, the sides across from the angles correspond. So if you have that situation, it kind of looks like the Pythagorean theorem. Not kind of, it's built off of the Pythagorean theorem. So we have little a squared is equal to little b squared plus little c squared minus 2 times little b, little c, cosine big A. And here are the rest of them accordingly to what you're given. So we're going to use these to solve some oblique triangles. Okay, example 1 says, given little a is 4 centimeters, little b is 7 centimeters, and little c is 9 centimeters. Solve triangle ABC. So what we have here is we have just like what we were talking about the first time. We have side, side, side. So just like we did law of sines, we're going to do a little key up here so we can keep all of our information straight. Okay, so we're going to fill in what we know. We know little a is 4 centimeters. We know little b is 7 centimeters. And we know little c is 9 centimeters. So we've got to find all of the angles. Now, in this particular example, it does not matter which one you find first. I always like to go alphabetically because we have all little a, little b, little c, and we're missing the angles. So I'm going to go back here. So it's like we have all of this information, but the only thing we're missing is the angles. So I'm going to find big A first. So let's be organized. We're going to say, all right, we're finding big A. So we got to use the law of sines that the law of cosines that has big A in it. So the law of cosines that has big A in it is little c squared is equal to, little a squared. Little a squared is equal to little b squared plus little c squared minus 2 times little b, little c, cosine of big A. Okay, so now we need to plug in all of our variables that we know. We know all the little letters. So little a, we have 4 squared is equal to little b, which is 7 squared, plus little c, which is 9 squared, minus 2 times 7 times 9 times cosine of big A. So we're going to go through this, and what we're trying to do is we're trying to get cosine of big A all alone, isolated by itself. Because remember, we talked about a couple days ago, if you've got a missing angle, you can use the inverse to find it. So we need to evaluate what these squares are first. 4 squared is 16. 7 squared is 49. 9 squared is 81. And I'm going to go ahead and multiply all of this out. So 2 times 7 times 9 gives us 126. We still have cosine of big A. Remember, that's what we're trying to get by itself. Now, this is just like 126x. So we need to add these together first. So you have 16 is equal to, and then 49 plus 81 is 130. Minus 126 cosine of big A. Now, the biggest mistake people make is they try to combine these. We can't. They're not like terms. So our next step algebraically is to subtract 130 from both sides. And yes, you're going to wind up with a negative number, and that's fine. So 16 minus 130 gives us 114, negative 114, excuse me. And we still have negative 126 cosine of big A. So that negative 126 is being multiplied. So we're going to divide by negative 126. Those cancel. And we get 0.905 is equal to cosine of big A. So, like we were talking about earlier in this unit, what we have here is we need to find this missing angle. So here we've got to do our little switcheroo like we were doing a couple days ago. So we're going to take these, do a little switcheroo. So we've got cosine inverse of 0.905 is going to give us what angle A is. And make sure your mode is in degrees, and you come up with 25.2 degrees. How's that? So let's fill in our chart. Now at this point, you've got enough information to find angle B or angle C, but you can actually use the law of sines. So at this point, if you want to say, well, scratch the law of cosines, let's work on the law of sines, that's fine, because it's a little bit shorter. So let's use the law of sines to find big B. So we have to use the part of the law of sines with B's, but we also have to use the law of sines where we have the complete set. We have the big and the little of the A's. So we've got to use the A's. Okay, so now we're ready to plug in. Little b's what we're missing, so we have 7 over sine of big B, and we just found big B to be 25.2. And that's equal to little a, which is 4 over sine of big A, and big A is, oh, oops, messed up plugging in here. That should be B. Jump the gun. Big A is 25.2. Sorry. Now, this is just like what we were doing before, except we're going to have to do the inverse at the end to find out what big B is. So we need to cross multiply. So we've got 4 times sine of big B, and we don't know what that is, so we're just going to write 4 times sine of big B. Then in your calculator, you can put 7 times sine of 25.2. And you get 2.980. Then we've got to divide by 4 on both sides. So do 2.980 divided by 4, and you get 0.745. Then all we have to do is do our little switcheroo. So we do sine inverse of 0.745, and that's going to give us big B. So press second sine 0.745, and you get 48.2 degrees. And if you use the law of cosines, you'd get the same thing. So let's put it in our chart. The last thing we got to find is big C, and we can go back to the fact that all 3 angles are going to add to 180. Oop. Let me fix that. 48.2. So now let's find big C. Well, we know big A plus big B plus big C is equal to 180. So big A is 25.2 plus big B, which is 48.2, plus big C is equal to 180. So let's add 25.2 and 48.2. And you get 73.4. So we have 73.4 plus big C is 180. And if you subtract 73.4 on both sides, you get that big C is 106.6. And we have solved that triangle. Okay, let's do another example. We're going to do one with side angle side. So let's take a look at example 2. We're going to go ahead and do our chart. This time we're talking about triangle JKL. Alright, let's fill out what we know about triangle JKL. We know that little j is 8 inches. Little k is 14 inches. And big L is 44 degrees. Okay. So we've got to figure out which one we can actually find first. If you go back to our formulas, they're in A's, B's, and C's. But that's okay. We can rewrite them with J's, K's, and L's. So I'm going to flip over to the next slide and rewrite them with J's, K's, and L's. Here are our formulas in terms of J's, K's, and L's. And this is really easy to do. You just substitute in J for A's, K's for B's, and L's for C's. So we need to decide which one we can actually find first here. So remember, we're given little j, little k, and big L. So I'm going to go through and I'm going to highlight little j, little k, and big L's. J, J, okay. So if you take a look at these, after I've highlighted what I do have, there's only one of these formulas that has only one unknown, and that's the last one. So we have to find little L first. So we're going to find little L. And here's a hint. You always are going to find the little letter, what you're given the big letter for, first. So we have little L squared is equal to little j squared plus little k squared minus 2 little j, little k, cosine of big L. So let's plug in, and we've got to find little L first. So we've got little L squared, which we don't know yet, is equal to 8 squared plus 14 squared minus 2 times 8 times 14 times cosine, and this time we actually have the angle, so we can go ahead and plug it in there, 44. So actually, we could go ahead and find a value for all of this. We can put it all in the calculator, but you need to be very careful with parentheses. So when you put all of this in the calculator, you end up with 98.868. And then finally, to get your L by itself, if we take the square root of both sides, we get L equal to 9.943. And that's our value for little L. Now, since we actually have a full set of letters now, we got big L and little L, we can use law of signs to find either big J or big K. I like to go in alphabetical order, so I'm going to go ahead and I'm going to find big J next. So for big J, we've got to use the part of law of signs where we use our J's. So little j over sine a big J, and then we got to use what we have a complete set of, and we have a complete set of L's. Okay, so little j is 8 over sine of big J, we don't know what big J is equal to little l, which is 9.943, over sine of big L, and big L is 44. Okay, so let's cross multiply. For this, we get 9.943 sine of big J and then we have 8 times sine of 44, and we get 5.557, and then we need to divide by 9.943. Those cancel. So sine of big J, we have 5.557 divided by 9.943. We get 0.55 unless we're round that to 9. So then lastly, we've got to do our little switcheroo. Take these, switch them, and we're going to do the inverse. And we get 34 degrees. So that is big J. And lastly, to find the last angle, simply add the two angles together and subtract them from 180. So we've got big K. So we know that big J plus big K plus big L is 180. We just found big J to be 34 degrees. We don't know what big K is. Big L is 44 degrees. If we add together the 34 and the 44, we get 78. Then lastly, subtract 78 from both sides. And we get that big K is 102 degrees. And there you have it.